Hi, this is Mrs. Kidman, and in this video, we are going to be discussing special right triangles. So when we talk about special right triangles, what we're referring to is right triangles that have special angle measurements. So there are two kinds of special right triangles that we're going to talk about, a 45-45-90 and a 30-60-90. So a 45-45-90 is a right triangle in which two of the angles are 45 degrees, and then we have our 90-degree angle. Now, they have a very special pattern that they follow when it comes to the sides of these right triangles. Now, the two sides, the two legs of our right triangles here are both going to be some term. And the pattern is that both those legs are the same. And remember, that's going to be the case because the opposite angles are the same. And then our hypotenuse is going to be whatever the length of the leg is times the square root of 2. Okay, so the cool thing about it is if we're given either one of the legs or the hypotenuse, we can always determine what the other one is. Either if we're given the leg, we can multiply it by root 2 to get the hypotenuse, or if we're given the hypotenuse, we can divide it by root 2 to get the leg. Cool, right? Okay, now let's take a look at the other type of triangle that we're going to see. This is called a 30-60-90 triangle because one of the angles is 30 degrees, one angle is 90 degrees, and one angle is 60 degrees. Now, just like with the 45-45-90, there are relationships between the legs of this right triangle and the hypotenuse. So when it comes to, there are two legs on this 30-60-90 triangle, a short leg and a long leg. And then when we're referring to these lengths here, we're actually referring to the lengths of the different sides of the triangle. So that word long is going to be the same as our hypotenuse. And then the short and medium refer to the two legs. The short is the shortest leg, the medium is the longer of the two legs. So to go from our short to our hypotenuse here, what we're going to do is multiply by 2. To go from that hypotenuse to our short leg, we're going to divide by 2. Similarly, to go from the short piece to our medium piece or the other leg, we're going to multiply by the square root of 3. And to go from the longer of the two legs to the shorter leg, we're going to divide by the square root of 3. So what we're going to do in this video is we're going to use the properties of these special right triangles to determine different side lengths based on the information that we're given. So let's take a look at these 4 examples here. First, we want to find the value of the variable and then write it in simplest form. So I want to figure out what x is here. Now remember, the property in this triangle where these two sides are the same means that these two angles are the same. So it's a 45-45-90. And the rules that we have with that 45-45-90 is, remember that to go from the leg to the hypotenuse, we're going to multiply by 2. But if we're given the hypotenuse and we want to go to the leg, we are going to divide by the square root of 2. So in this case, we want to divide both sides by the square root. We want to divide our hypotenuse by the square root of 2, which means that x equals 2. Awesome. Okay, now let's take a look at this next example here. Now this next example is also going to be one of those 45-45-90 triangles. But in this case, our two legs are both the square root of 2. So to go from a leg to a hypotenuse, we're going to multiply by the square root of 2. So we're going to take the square root of 2 times the square root of 2, which is the same thing as the square root of 4, which equals 2. So that means that our length y, or our hypotenuse here, is going to be 2. So do you see how we can apply those properties? Now for questions 3 and 4, these are both actually going to include 30-60-90 triangles. So here's just our quick review on that. To go from the shorter of the two legs to the hypotenuse, we are going to multiply by 2. To go from the hypotenuse to that short leg, we are going to, divide by 2. Who would have guessed? To go from our short leg to our longer leg, what we're going to do is we're going to multiply by the square root of 3. And to go from the long leg to the short leg, we're going to do the opposite and divide by the square root of 3. Okay, so now that we know this information, let's determine what these different lengths are. So we're trying to solve for x here. So this square root of 3 is actually our shorter length. So x is going to be equal to the square root of 3 times the square root of 3. Now, a square root can cancel itself out if we multiply it by itself. So this is actually going to be the x equals 3 there. Fantastic. Now, question number 4, I also said was a 30-60-90 triangle. And you might be looking at it and being like, this is not a right triangle. But this is something that's really interesting. Anytime that we have an equilateral triangle, if we draw the altitude or the height right down the middle of our triangle, what that does is it actually divides our triangle up into two 30, 60, 90 triangles. And the reason why we know that is because remember, in an equilateral triangle, all the angles are the same. So they're all 80 degrees. But when we put in that altitude or that height, it divides that angle exactly in half as an angle bisector. Therefore, both sides of the angles are each 30 degrees. And then we have that 90-degree angle in the middle. So in this case, we want to figure out what is the height. So we've got this triangle. I'm going to redraw it over here. And our short leg is 2. Our hypotenuse is 4. So what is our shorter leg here? And they label it with an H. Well, how can we find that? Remember, to go from the short leg to the long leg, we can just multiply by the square root of 3. So our height equals 2 times the square root of 3, which, as simplified as it gets, is 2 square root 3. So that's going to be the height of that triangle. Okay, so that's basically how those apply. Now let's take a look at a couple of application problems in which we might use this in the real world. So for example, here, the road sign is shaped like an equilateral triangle. Estimate the area of the sign by finding the area of the equilateral triangle. Well, in this case, I know that this distance is 36, which also means this distance is 36 and this distance is 36. Now, as we saw in that previous example, if I create the height of this, this actually creates those 30, 60, 90 triangles. So 30, 30, 60, 60. And if this length is 36, each individual piece right here is going to be half of that, which is 18 inches. So as those are 18, what that means is we now need to find the length of the long leg to then determine what the area is, because we need to find that altitude or that height. So to find the length of that long leg, remember to go from the short leg to the long leg, we are going to multiply by the square root of 3. And so that's what we're going to do here. We're going to do 18 times the square root of 3. That is what this piece is. Awesome. Okay, now to find the area, remember it's going to be 1/2 base times height. So in this case, we're going to do 1/2 the base, which was 36, times the height of our triangle, which is 18 times the square root of 3. And as we type that into our calculator here, we can get that all solved out, and we end up seeing that this 1/2 times 36 times 18 square root of 3 ends up equaling 561.18 inches squared. Cool, right? So I love how, even though we're given an equilateral triangle, with just knowing that one side, using these special properties of these special right triangles, we can actually determine what the altitude or the height of that equilateral triangle is. How awesome is that? Okay, let's take a look at one more example here. We are going to look at this one here. So this one is a tipping platform that's a ramp used to unload trucks. And they're wanting to know how high is it when the 80-foot ramp is tipping at a 30-degree angle or 45-degree angle. So basically what we're looking for is what is the length of the short leg if we know that our hypotenuse is 80 and this angle is changing. So let's take a look. I actually also want to look at 60 degrees and see how those three numbers change. So what happens when it's at 30 degrees? Well, when it's at 30 degrees, the height here is going to be our shorter leg, right? And so in that case, our shorter leg and the hypotenuse have that special relationship where we divide our hypotenuse by 2 to get that length of the short leg. So if this is the 30, that means this is the short leg. And so 80 divided by 2 is 40. So at 30 degrees, the truck is 40 feet off the ground. Okay, what about if we were at 45 degrees? Now, when we're at 45 degrees, there's actually a different pattern that we're going to follow. So if this one was actually 45 degrees, the relationship between the leg of a triangle and the hypotenuse, if we know the hypotenuse, what we're going to do is we're going to take our hypotenuse and divide it by the square root of 2. Because remember, when it comes to a 45, 45, 90, the two legs are both whatever it is, and the hypotenuse is the length of the leg times the square root of 2. So to go backwards, we're going to take that 80 and divide it by the square root of 2. And we're going to end up getting that height there of the truck is 56.7 feet off the ground. Awesome. Now, what we want to ask ourselves is what happens? Now, this is interesting. What happens when this becomes 60 degrees? Well, when this becomes 60, this is actually 30. So the side that's going to be smaller is actually going to be this one, and this one's going to be whatever x is times the square root of 3. So if this is the shorter side, we know that that makes this side 40 because it's half of our hypotenuse. But to get the height of the ramp, we are going to need to do, so at 60 degrees, the truck is at whatever 40 times the square root of 3 feet is. And as we do 40 times the square root of 3, we end up getting 69.3 feet off the ground. Okay, so you can see that as we adjust that triangle, the shape and the sides that we're looking at really adjusts. So in all three cases, that 80 represented our hypotenuse. But in the first case, we were looking for the length of the shorter leg. In the second case, where it was 45-degree angles, we were looking for the legs, which should be equal. And in the third case, when our angle was 60 degrees, we were looking for the longer leg. So we kind of had to do a roundabout method by finding the shorter leg first and then using that to find the longer leg. But this is how we can use special right triangles in the real world. So we often see it when it comes into things. It comes into play anytime we have right triangles, especially when they have those angles of 45 degrees or 30 or 60. So if you have any questions, feel free to reach out. But again, that is special right triangles for you. So again, a 45, 45, 90 triangle, the legs are the same length and the hypotenuse is one of the legs times the square root of 2. In a 30, 60, 90 triangle, the shorter of the leg has a special relationship with the hypotenuse. So the hypotenuse is twice the length of the shorter one, and the other leg is the length of the shorter one times the square root of 3. You have questions, feel free to reach out, but that is special right triangles for you.